Hello everybody! This video follows Chapter 1, Section How Economists View the World, Models and Assumptions. Reality includes so many variables that it's impossible to study them all at the same time. Models are deliberate simplifications of reality, so you learn something by only focusing on a few variables at a time. For instance, assume your job is to predict sales of ice cream in different counties. You can come up with a mathematical model where sales of ice cream is a function of weather, population, and income. Now, why weather? Well, if your county is in the North Pole, you're probably not going to sell a lot of ice cream over there. On the other hand, the larger the population, probably the more ice cream you're going to sell. And also, the richer the population, the more ice cream you're going to sell as well. However, one can think of other variables that could affect sales of ice cream as well. For instance, preferences. Do people in the county like ice cream? Or culture, the habit of eating ice cream, or the age structure of the population. If the population is younger, if there are more children, you're probably going to sell more ice cream, assuming children like more ice cream than adults. What about the number of vacation days in the period considered? The point I'm trying to make is, if you think hard enough, every variable affects every variable. The amount of variables that can affect the sales of ice cream is just gigantic. One would be lost in all the math involved. It's impossible to study reality as it is because it is too complicated. We have to come up with models. Models, again, are deliberate simplifications of reality. We include some very important variables and focus on those. Then you can actually learn something. Now, my favorite way to explain this is to use the example of a map. Imagine a map of Murray State that contains every single possible detail of Murray State. Every leaf in every tree, every crack in every pavement, every detail in the roofs. Basically, it's a very super accurate map. The size of this map is the size of Murray State, and this map is completely useless. It is a gigantic map. There's no way I can even open it. On the other hand, consider a map that simplifies reality. For instance, let's simplify the business school to a rectangle. And then the 16th Street, where the business school is, assume it's just 2 lines. Now notice the gigantic simplification of reality. The business school is not a rectangle. It's a building. It's not even in the shape of a rectangle. And the 16th Street is certainly not only 2 lines, so a really simplified reality. But now, I can draw this map, and it can actually be useful. I simplified it so I can focus my thinking, and then I can learn something from it. So that's what a model is, a simplification of reality, so I can actually focus my thinking and learn. Now, some familiar models that we've seen in our lives. A model of human anatomy from high school biology class. That was a model, a simplification of reality. The human body is much more complex than in this model. Now, a model airplane, also a simplification. A real airplane has much more details. The model in your dentist, a model teeth at the dentist's office. Okay? So models are used in all science, physics, chemistry, etc. It's impossible for any science to study reality or the universe as it is. We have to make some simplifying assumptions so we can focus our thinking. Now, there are different kinds of models. Mathematical models, that's the one you were talking about. You basically write the equation of the variables we are trying to predict. In our example here, sales of ice cream was a function of whether income and the size of the population. Now, we can compare that with a literary model. A literary model, it would just be a translation of the math to English. For instance, you can say that the sales of ice cream, sales of ice cream is affected by weather, income, and the size of the population. So basically, you are stating that in English instead of using a math equation. Now, the advantage of using math is because it's much more precise. But many people prefer literary models just because they're not comfortable using equations. Well, a third kind of model is a visual model, like a geometric model, such as flow diagrams, graphs, etc. Those are actually mathematical models as well. What happens is that graphs are geometric representations of equations. So you're actually talking about the same kind of model, but looking at it in a different way. It is key when constructing a model to decide what assumptions to make. There are two risks: including too many variables or excluding important variables. So, in our example of the map, here we had the business school, and here we had 16th Street. That's a part of the map. Again, if you include too many variables, it's impossible to use a map. If you include every detail of the business school, every detail of the trees, every detail of the pavement, the map will be the size of Murray State, and we will not be able to even open it. On the other hand, what happens if I simplify my map even further and assume there are no streets at all? Then my map got so simplified, it's useless, because if I assume there are no streets, how do I know which street the business school is located if I am assuming there are no streets at all? So, two risks: include too many variables so I cannot focus my thinking, or exclude so many variables that thinking is not possible anymore. Now, one important type of simplification, one important type of assumption we'll be making all the time is the so-called ceteris paribus. Ceteris paribus means everything else constant. It is a very famous assumption in economics. Here's an example why it is important. Let's say you want to study how quality of life may affect job growth. So what you have here is job growth as a function of quality of life. Okay? However, you have to make sure you are comparing two regions with similar economic growth. Why is it the case? Let's say that region A has poor quality of life, but is fast growing. Now let's say that region B has high quality of life, but the economy is not growing, is stagnated. Then it may be the case that a lot of job is being created in region A, but it's because the economy is fast growing, not because of the poor quality of life. On the other hand, in region B, it may be the case that there is no job creation, but that's because the economy is not growing, not because of the high quality of life. If you ignore this part, you may come up with the conclusion that the poor quality of life promotes job growth. But that's not the case at all. What's going on here is that the economy is growing. That's why the number of jobs is growing. It's not because the quality of life is poor. That has to do with not including important variables in your model. That's actually another way of saying the same thing. So what you have to make sure is, make sure A and B, the regions you are comparing, have similar levels of economic growth. Then you can isolate the effect of quality of life on job creation. Thanks for listening, everybody.